In this video, we will talk about how to divide two numbers in scientific notation. So I have three examples for us to work through here. Let's check out this first example. We have 6 times 10 to the 8th divided by 2 times 10 to the 4th. So to divide these two numbers that are in scientific notation, here's what we do. We take the coefficients, so the numbers out front, and we divide them. So we'll do 6 divided by 2, and then we simply divide the numbers that have 10 as their base. So 10 to the 8th divided by 10 to the 4th. So when we do that, we get 6 divided by 2 is 3, and then we have times. Now, when we're dividing two numbers that both have the same base, so they both have a base of 10, all we have to do is take the exponent in the numerator, so the 8, and subtract the exponent in the denominator, so 4. So we just do 8 minus 4, which is 4. So we get times 10 to the 4th. So that's our answer for this one. All right, let's try another example. We have 8 times 10 to the 3rd divided by 4 times 10 to the 5th. So we'll use the same process that we did in the previous example, where we take the coefficient in the numerator and we divide it by the coefficient in the denominator. And then we take the number that has a base 10 in the numerator and we divide it by the number that has base 10 in the denominator. So let's see what we get. 8 divided by 4, that's 2. So we have 2 times. Now we said when we have two numbers that have the same base, so they both have a base of 10, all we have to do is take the exponent in the numerator and subtract the exponent in the denominator. So 3 minus 5, that's negative 2. So we end up with 10 to the negative 2. So that's our answer on this one. All right, let's try one more example. We have 2 times 10 to the 7th divided by 5 times 10 to the 3rd. So to perform this division, we'll take the coefficient in the numerator, the 2, and we'll divide it by the coefficient in the denominator, this 5. And then we'll take the base 10 number in the numerator and we'll divide it by the base 10 number in the denominator. So we get 2 divided by 5. So if we want to write that as a decimal, here's how we can do that with a little long division. We can say 2 divided by 5. So we ask ourselves, how many 5s go into 2? Well, 5 can't fit into 2 because it's bigger than 2. So we'll just say 0. Now the 2 has a decimal point right here. And after the decimal point, we can imagine there's a 0. So 2 is the same as 2.0. Now what we can do is we can move this decimal point up here into the quotient. And now we can ask ourselves, how many 5s go into 20? So treat this as 20. Well, that would be 4. So we'll put a 4 right here. So 5 times 4 is 20. So we get 20 minus 20 is 0. Now when we end up with a remainder of 0 like this, that tells us that we're done with our long division. So 2 divided by 5 is 0.4. So let's write that over here. 0.4, and then we can move on to the base 10 numbers. So the exponent in the numerator is a 7, and the exponent in the denominator is a 3. So all we have to do is 7 minus 3, which is 4. So we get 10 to the 4th. Now, for a number to be in proper scientific notation, the coefficient, the first number, needs to be between 1 and 10. So we can see that 0.4 is not in that range right now. But we'll notice if we take the decimal point and we move it 1 to the right, we can convert this 0.4 to just a 4. So a 4. Now, the rule of thumb is the number of places that you move the decimal place to the right is the number of values that you need to decrease this exponent by. So 0.4 times 10 to the 4th is the same as 4 times 10 to the 3rd. So we just converted the 4 to a 3. The other rule of thumb that you might want to know is that if you're moving the decimal place to the left instead, the number of places that you move the decimal place to the left is the number of values that you increase the exponent. So just keep that in mind. So this is our final answer on this one.